Now, coming to the third math problem. In this math problem, it says that a satellite is revolving the Earth in a circular orbit. In a circular orbit near the Earth's surface. What additional velocity is to be given to the satellite so that it may escape the Earth's gravity? So I have to find out what additional velocity is to be given to the satellite so that it may escape Earth's gravity. And here there is two additional information. The radius of our Earth is 6.4 into 10 cube meter. Not 10 cube, is 10 to the 6. 10 to the 6 meter, and our gravitation acceleration g equals to 9.8 meter per second square. Okay, this additional information also given to us. So we know for a satellite its orbit velocity or v naught is actually equals to root over gm by r plus h. Okay, and we also know gm equals to gr square. Gm equals to gr square. So from that we can write this thing as g r square by r plus h. R plus h. This is okay. Okay, but here it says that the satellite is revolving the Earth in a circular orbit near the Earth's surface. So suppose this is our Earth, and suppose this is the satellite which is revolving near the Earth's surface, which is actually at a height h from the Earth's surface. As this h is very small than our radius r, so that instead of h we can write this thing as gr square by r. Okay, because this h is very small than this r. So from that we can write this thing as root over gr. So this is the orbit velocity, or this is the revolving velocity of our satellite near the Earth's surface. So we know to escape from our Earth's surface or from the Earth's surrounding or Earth's gravitation, the velocity will be equals to root over 2 g r. Okay, root over 2 g r, and this is very large than this velocity. So what additional velocity you have to given? So this is the difference between this escape velocity and this orbit velocity. So this difference of this velocity is actually ve minus vo, which is actually root over 2 gr minus root over gr. Okay, so we can write this thing as actually like this: root over 2 into root over gr minus root over gr. If I take root over gr in common, then I can write this thing as root over 2 minus 1. So if I put the value of g, which is actually 9.8, and r is actually 6.4 into 10 to the power 6, and here I found out the root over 2 minus 1. If I calculate this whole value, then the additional velocity will be 3.36 into 10 to the power 3 meter per second. So this is the velocity. We have to add this velocity with this orbit velocity so that the satellite escapes our Earth's gravity. I hope you understand this problem. Now coming to our fourth problem, it says that an Earth satellite makes a circle around the Earth. So this is our Earth, and this is suppose a satellite, and makes a circle around the Earth in 90 minutes. So the given time period of the satellite is 90 minutes. Okay, or we can say this thing as 5400 seconds. Okay, 90 minutes. I have to calculate the height of the satellite above the surface of the Earth. I have to find out the height of the satellite. So let the height will be h. So let the height be h. Okay, so we know equation. Oh, there are additional two information given. One is the radius of our earth r is 6400 kilometer, and our gravitational acceleration g is 9.8 meter per second square. These two additional information are given. Okay, so here our time period is 90 minutes or 5400 seconds. We know the time period of a satellite, or the equation of the time period of a satellite is t equals to 2 pi root of r plus h whole cube by g of n. So if I solve this equation for h, then for this h height, I will find out this equation is t square into gm divided by 4 pi square whole to the power 1 by 3 minus r. But the value of gravitational constant and mass of our earth are not given. Though we know the value of the gravitational constant, but our mass, earth mass, are not given. But there is two additional information are given. One is our gravitational acceleration and the radius. We know g is actually equals to gm by r square, or you can write this thing as gm equals to small g r square. So we substitute this capital Gm with g small g r square. Then I will get t square into g r square by 4 pi square to the power 1 by 3 minus of r. Now if I put all of this value, then I will get 5400 second square into 9.8 into r is actually, if I take this value, this is our in kilometer unit. If I convert this in SI unit, then I will get 6.4 into 10 to the power 6 meter. So 6.4 into 10 to the power 6 square divided by 4 pi square into to the power 1/3 minus 6.4 into 10 to the power 6. Okay, if I calculate this value, then I will get 0.268 into 10 to the power 6 meter. So which is actually equals to 268 kilometer. 268 kilometer. So this problem is solved, which says that the height of our satellite is 268 kilometer. So I hope I touch all the formula to solve this. I hope I touch all the formulas of gravity and gravitation to solve this 4 math problem. I hope I understand the concept of this math problem and how to approach for this kind of problem. If you like this video, do subscribe to our channel. Thank you.